The conjugate of surds are two surds that you can multiply to give us a rational number. For example, surd x plus surd y bracket surd x minus surd y. So this is the conjugate of this, because they are conjugate surd, because when I multiply them, I'll have a rational number. That is to say, surd x times surd x will give me x, because surd x times surd x give us surd x squared, which is x, plus surd x times surd y will give us xy. This times minus, then plus surd y times surd x give us plus xy, and plus surd y times minus surd y will give us minus y. So this will cancel this, give you x minus y. So because I have multiplied these two surds, it gave me a rational number. There is no more in surd. That is why they are called conjugate surds. Conjugate surds are two surds that when multiplied, it will give you a rational number. That means a number without a surd. Rationalization. Of surds. Now, to rationalize a surd is to handle this surd in such a way that you are going to get a rational denominator. That is called rationalization. The way you handle this surd to make sure that you have a rational denominator. That's to say that if you have evaluate 10 surd 2, you see you have irrational denominator surd 2. So what will you do? You are going to rationalize this surd so that you can have a rational denominator. That means a denominator without a surd. So solving a problem like this, you have 10 root 2. You are going to multiply the numerator and denominator by that denominator. Once you have done that, you have done what we call rationalization, because that's the only way to get a rational denominator. To say root 2 over root 2. As you can see, this can go out, you still get back your number, so you did not even change anything. You only change the physical appearance of your question. This will give you 10 times surd 2, 10 surd 2. Remember what we did when we were multiplying fractions. And root 2 times root 2 will give you root 4, which is 10 root 2 all over. What is root 4? Root 4 is 2. As you can see, you have succeeded in turning the denominator to rational number. But finally, you can cancel here. You cannot cancel 2 in the surd with the 2 that's not in the surd. You can only cancel 10 outside the surd and 2 that's not in the surd to have your final answer as 5 SURD 2. It is that simple. This is called rationalization of SURD. What you do to make sure that the irrational denominator is removed. More questions. Evaluate two plus SURD 3 all over 7 minus SURD 5. Question like this is very simple. You will say 2 plus SURD 3 all over 7 minus SURD 5. What will you do? The denominator is very irrational. So what do? We will have to make sure that we rationalize this to have a rational denominator. So to do that, you multiply the numerator and denominator by the conjugates of the denominator. Remember what you said? What's the conjugate of 7 minus root 5? It is 7 plus root 5. Like what I showed before. Conjugate of SURDs. Flashback. You have 7 plus root 5 all over 7 plus root 5. Very simple. So this will give you, you know how we handle fractions when it comes to multiplication. You multiply the numerator and multiply the denominator, all independent of the other. So you say 2 multiplied by 7, you have 14. 2 multiplied by root 5. Okay, let me put it like this for proper assimilation. 2 plus root 3. 7 plus root 5. 7 minus root 5. 7 plus root 5. This will give us 2 times 7, 14. 2 times root 5 plus 2 root 5. Again, 3 root 3 times 7, 7 root 3. Root 3 times root 5, root 15. You see this one? If you can remember what we did in conjugate of SURD, you wouldn't need to worry yourself in expanding this. But now let us expand it first. You know, this is what we call difference of two squares. 7 times 7, 14. 7 times plus root 5, 7 root 5. Minus root 5 times 7, minus 7 root 5. Minus root 5 times plus root 5. Minus times plus, minus. Root 5 times root 5, root 25. Or you write 5. So this will give us 14. 2 root 5 plus 7 root 3 plus root 15 all over 14 plus 7 root 5 minus 7 root 5 will go. This will go with this because they are the same thing. Minus, what is root 25? Is 5. So your final answer becomes, as you can see, root 5 and root 3 are not the same thing, so I can't add them. And root 15 cannot be splitted because we only have 3 and 5. 3 times 5 is 15. 3 does not have a perfect root. 5 doesn't have a perfect root, so I cannot split them. So I can only say that 14 plus 2 root 5, 7 root 3, root 15 is all over 9. And at this point, you won't be able to move further, and that becomes your final answer. Let's do more example on this sort. More example. Example 3. Evaluate. One over root 7 minus 1 minus 1 over root 7 minus 3 is equals to a plus b root c. Find the values of a, b, c. Okay, look at this. 1 all over root 7 minus 1. 1 all over root 7 minus 3. What do we do? Look at this. It's a fraction. It's a fraction. And minus separating the two fractions. What do? We take the LCM of the fraction. So the LCM here is root 7 minus 1 bracket root 7 minus 3. Root 7 minus 1 divided by this, multiply by 1. You have root 7 minus 3 minus this by this, you have root 7 minus 1. This will give us root 7 minus 3 minus times this minus root 7 minus times minus 1 plus 1 all over. Open the bracket. Root 7 times root 7 will give you 7. That is root 49. That is 7. Root 7 times minus 3. 3 root 7. Minus 1 times this minus root 7. This times this plus 3. This will give us this root 7 minus root 7 will taken away. Minus 3 plus 1 will give you minus 2 remaining. Then 7 plus 3, 10 minus root 3 minus root 7 minus root 7 minus root 7 will give us minus 4 root 7. At this point, look at this. You can now rationalize at this point to make sure that you removed this irrational denominator. Minus 2 10 minus 4 root 7 multiplied by 10 plus 4 root 7 all over 10 plus 4 root 7. The conjugate of this denominator is 10 plus 4 root 7. Multiply up and down with it. You have minus 2 times 10 minus 20 minus 2 times plus 4 root 7 minus 8 root 7. 10 times 10, 100. 10 times 4 root 7, 40 root 7. Minus 4 root 7 times 10, minus 40 root 7. Minus 4 root 7 times plus 4 root 7. You have minus times plus minus. 4 times 4, 16. Root 7 times root 7 give you 7. You have minus 20 minus 10 root 7 all over. This will go with this. You have 100 minus 16 times 7 will give us what? 7 times 6 is 42. You write 2, carry 4, 7 times this 7 plus this plus 4 will give us 1. This will give us 20 minus 10 root 7 all over. Subtract 100 minus 112. You are owing 112, you have 100. When you pay, you are still owing 12. What will you have? To divide this, you ask yourself, what is there in 12 and is here? Because I am intending in making it look like what I'm asked to get. I'll be having minus 2, 10 plus 5 root 7. Sorry. All over minus 2 brackets minus 4 will give us 5, give us 2, 4 will give us 3. So minus 4 is out, 5 is remaining. Minus 4 is out, 2 is remaining. Minus 4 is out, 3 is remaining. So this and this are the same thing. But this will enable us reduce this. So we can cancel minus 4 and minus 4 to have our final answer. We have 5 plus 2 root 7 all over 3. Remember what we said in division of fractions. This will enable us to have 5 over 3 plus 2 over 3 root 7. So the 3 will divide here and divide here to give us this, such that A is 5 over 3, B is 2 over 3, and C is 7. That's our final answer. Here comes to the end of surd and its operation, we will be treating number basis, that's number system, in our next class. Thank you for enjoying the class, and see you again.